everyone for joining us today. So I'm Gerard from Zenika, and today we have a night class, and I'll be speaking about building for readability and performance in Google Sheets. So today we'll be covering a number of areas. First, we'll start off with what are some of the good use cases of Google Sheets, when it's a great use case, under those circumstances, why is it great? And when it's not so great, and you probably want to consider other tools and platforms. Then we'll move on to kind of the meat of the talk, where we talk about specific techniques that will help you improve performance and readability of the Google Sheets you create, followed up by some general tips. And at the end of the session, well, I'll kind of an e-souvenir that you can all copy and take home. It's a savings calculator that I built. So I'll be using that to discuss implementation of some techniques, why I chose to use some of them, why I didn't. And it's something that, if you want, you can take home, dissect, play with it, expand upon it, and so on and so forth. So first, I'll talk a bit about when Sheets is a great tool. So in today's day and age, we have a lot of software tools, a lot of very powerful hardware at our disposal, a lot of pretty advanced services that probably were not so easily available 10 years ago. But Google Sheets is still, it still has its use case. You don't always need a power tool to solve your problems or tackle them. Sometimes you just need a simple multi-tool or a pocket knife, and Sheets is like that. So in today's age of big data, where we can crunch terabytes, petabytes of data for particular use cases, sometimes we don't have to. For many cases, we don't need to approach that level of data size, and Sheets can tackle that. So under about 1.5 million cells, this includes all the cells in your entire workbook. So everything from your presentation interface with where your user interacts, to every single data tab and data cell, every single cell you're using for your calculations, where you're storing your configuration values, etc. Everything, as long as that's at about 1.5 million, plus your calculations and formulas, that's kind of the limit I found personally, that after which even a 4-core 16 gig machine starts to become very slow and potentially unresponsive. And even going beyond this size doesn't really give you more performance. Google Sheets isn't really able to leverage much more hardware beyond this spec. Personally, I've tried going up to 128 gigabyte virtual machine. I gave it 32 cores, and it did not actually help my monolithical spreadsheet go any faster. So there is a practical limit, and roughly about 4 cores and 16 gig of RAM is that limit. If you're using a more portable, less hardware intensive laptop, like maybe a dual core with 8 gigs of RAM or so, I found, approximately half of that, you'll start to kind of hit that same slowdown in user experience you get at a more powerful laptop at 1.5 million cells. So this kind of a rough benchmark. It may fluctuate a bit up or down depending, say, whether you're more data heavy with not so many calculations, or you may have a lot of calculations but not that much raw data. Another use case where Sheets is great is your application and your use case is simple enough where it's not necessary to modularize your application into multiple sections, like the database, your backend implements the logic, a front end that the user interacts with, load balancers, all this kind of stuff. Sometimes your application doesn't need that. It's kind of simple, small. Sheets is great. And one of the benefits of Google Sheets is that, at least the way I like to do it, is I create a Google Sheet. It's got, I make it public. It's a shareable link. Anybody link can just open it, view it, and everybody can make a copy. So once you make the copy, I don't have access to it. You get to put whatever you want in it. You can change it. I don't get to see it unless you explicitly share it back to me. So I think that's great. And data privacy is a concern, and I don't want to be responsible as a developer for managing data that I don't have to manage. And one nice thing about Sheets is that everybody has some level of spreadsheet experience, and allowing anybody to copy your spreadsheet, take a look at it, modify it, expand upon it, build upon it. I think that's really great, and Sheets is something that really empowers that. So why it's great? It's free. Free is always good. It's for average users and consumers. It's a more frictionless barrier to entry. Even in an enterprise setting on smaller scales, just not having to have something eating into your budget's great. For Google Sheets in particular, you don't need to install any local files. If I'm sharing something freely and publicly, people in general should be concerned. Don't just randomly, oh, Gerard from the internet has shared this thing, let me install it. Don't do that sort of thing. Not needing to install local files is great from a security perspective, as well as an ease of setup perspective. Another thing is that it's really easy to share. You just have a link, and I can share it via the link. I don't need to, send files, zip files, set up a Amazon bucket for people to go and access. It's just a URL. Google Sheets settles the the hosting and all that for me. It's an all-in-one package. So for smaller applications, you don't need to deal with your front end, back end, multiple services, things like that. You don't need to settle runtimes, etc., that other programming languages need to deal with. It's all in one. You just have the spreadsheet, access it via the web browser, and you're there. And yeah, like I mentioned earlier, once I share the spreadsheet, you make your own copy. I don't have access to that copy, which is great. And for one thing to note is that this paradigm mainly holds if there are no macros, because if there are macros, there could be arbitrary code inside which says, maybe copy something in the spreadsheet every so often and then, send it back to Gerard. So I try not to use macros for that reason, because when I share a spreadsheet, you copy it, you want to open it, when you get that security warning from Google saying, hey, this script wants access to your data, you shouldn't need to, know app script, understand the code, review it in order to decide whether is it safe to run this arbitrary code that Gerard from the internet just wrote. So I try to stay clear of that. And yeah, whatever I build, I share. Anybody should be able to, modify it, expand on it. Maybe you don't agree with the exact way I implement this feature. You kind of want to tweak it to your own use case. You could do that. You want to build on my use case, expand it, add more use cases. That's really great. Now we come to when is it not so great? So like I mentioned, when data volumes exceed the number of cells, memory, computational power, the spreadsheet could either go from really, really slow or just stop responding altogether. And this is not a problem that you can simply just throw more hardware at. There is a practical limit of hardware that Sheets can actually utilize. So beyond this, you will be better off going to proper, more formal software solutions. If you need to do regular releases and preserve and migrate existing data, Sheets is not a great way to do it. So, for example, if you're in a more formal environment, you may have databases and that's segregated from your application logic or business logic layer. You can update your business logic, you can add more databases, but what you have in your existing databases is preserved. In Google Sheets, if you've made a copy of a spreadsheet I created last month, I released a new version this month, we got to think about how you're going to migrate data from the one you copied last month to the one you just copied this month. So copy and paste is not great. If pasting using various writing a macro or something, then we run into the issue with macros and things like that. So in the cases where you want to continue the releases and preserve and migrate data from version to version, Sheets isn't the best platform for that. Next, on the UI side, Sheets can do some basic stuff, but especially with all the amazing code-based frameworks, no code-based frameworks out there, there are many solutions that give a much more polished UI options. And if that's something that's important to you, important for your use case, you should look beyond sheets. Next, as your application, gets bigger, more complex, more nuanced, you have multiple services you want to run. At that point, when the modularization benefits outweigh the overheads and cost of actually setting up the modularization, though that kind of architecture, that kind of platform, that's going to serve you better than sheets. And at that point, you should strongly consider moving out of sheets to those platforms. Next, there is not really a lot of options to incorporate many of the current software engineering best practices available today in Sheets. So Sheets doesn't have version control. If you have multiple developers working, it's going to be hard for you to fork, merge things back. It's hard for you to roll back and segregate changes in individual commits, things like that. In Sheets, you don't have the options for monitoring, alert, logging, that sort of stuff. Automated testing, again, is not something that comes with Sheets. And importantly, there's no real DevSecOps frameworks or options you can really use with Sheets. So if these things are important for you, especially like larger enterprise environments, moving to various cloud providers, other software solutions, those are some things you should really look at instead of Google Sheets. And lastly, especially in the paradigm where I like to use, where I share a template publicly, and then people can copy and make their own, make changes to their own copy and retain control of their own copy, the data they've keyed in, and so on. In that circumstance, the entire sheet is editable and accessible to the user. So it's easy to break things. They may accidentally, delete a particular range I'm using for calculations and so on. So in use cases where you need to be able to have users accessing only the front end, you don't want them to break the back end, maybe in an enterprise setting or a production setting, Sheets is not what you should be using. If your use case involves anything where you would consider, enterprise grade production environments, Sheets is really not where you should be looking. So next we come on to the actual, kind of techniques and things we can use to improve both the performance and the readability of Sheets. So first up is array formulas. I think some people might be familiar with it. It gives you both a performance and a readability benefit. And then there is the indirect function, which we'll go into. There's some interesting use cases there. And next up, we have name ranges, which is largely for readability. But like anything in code-based or low-code-based environments, readability is really important. Code spends most of its time being read, and a minority of its time being written. So prioritizing and making sure that the fact is being read most of the time, it's easy to read, can be read accurately, interpreted accurately by developers and users. That's really important. And last but not least, just formatting your formulas. We'll go into that in a bit more detail later. So again, for performance, you're never going to approach the level of performance of a formal programming languages, some of the really cool services and infrastructure options we have in these days. But optimizing a bit for performance in Sheets using these techniques can help you get closer to maybe having a 1.5 million cell practical limit on a nice zippy machine. It can help you get there, and once we get to that point, there's really a lot of use cases that you can do in Sheets. And the fact that you can do it in Sheets means it's lower effort. It's much more accessible for people to create stuff, much more accessible for users to tweak, play around with stuff, and that's something really great. So let's dive into the first one, array formulas. So I'm sure most of us are familiar with formulas where you reference specific cell, you may perform some operations on them, maybe you're referencing multiple cells like A1 times B2 and so on and so forth. And a lot of times you may have data in a tabular format, and you're dragging that formula downwards to encompass all the rows in the table. So array formulas, if you give it the entire column, like I did here, like D to D and C to C, you can cover the entire column, and you don't need to drag it down throughout the entire column, which is really great. So from a development effort perspective, you don't need to keep either double clicking or copy and pasting or manually dragging. And one really nice thing is that always, as you're iterating and developing, it removes all doubt about whether you updated the lower rows after you made the changes in the first row. And next, especially in the case where you have a full row formula like I did here, like D to D as opposed to D1 to D1000. As the number of rows in this table increases, the array formula automatically captures all those rows. You don't need to keep like, oh no, I added 1,000 more rows. I need to change the formulas from D1 to 1,000 to D1 to D2000. You don't need to do that. The array formula will deal with it for you. So one caveat, however, is that this does mean that you're a bit limited in what cells you can reference within an array formula. Array formulas, you cannot reference any cell that is both, that cannot be an input and an output. So for example, in this particular array formula here, I'm referencing cells columns D and C. So this formula cannot actually be in D and C. And D and C cannot reference this in an array formula. So otherwise that would cause a circular logic and your sheets will raise an error. So other than columns, restrictions on which columns can reference each other, if you're using columnar array formulas, you also can't reference, you can't do references like, oh, for this row, take the row above you and add 5. You can't do that sort of thing. So particularly in situations which I'll be demonstrating later, where I'm trying to do, say, year-on-year compounding interest, I can't use array formulas for that. I need to, use a regular formula where I just reference the cell above each time. So I did mention it improves performance. So we got a quick demo for this. Yes, need to refresh these. So one thing to take note of whenever you are trying to assess performance of your sheets, when they first open and load, sheets will try to make it responsive to you as quickly as possible. So sometimes it might not have loaded everything in the spreadsheet. It's going to load what's on the first tab, what's immediately visible. It may not load everything. So until you kind of open it, poke it, prod it, force it to render everything, it may actually get faster over time as you're interacting with it. And I think that is kind of the speed we want to measure, because if a spreadsheet's a little bit slow upon startup, not the end of the world. If it remains slow for the entire duration the user is using it, that's a concern. So here I'm just going to poke these spreadsheets a bit, just scroll to the end, just force them to render everything. Alrighty. So I'm just going to briefly explain a little bit about what these two sheets do. So it's going to accept an input in cell A2. Column C is just a simple row numbering from 1 to 1,000 in this 1,000 row table. Column D takes what the user inputs in the yellow cell, replicates it over all the rows. And from column E to I, we just have some arbitrary calculations. And it's a set of 5 calculations that references the cells before them. And I'm just repeating this all the way from column E all the way to column IY. So that's about 260-ish columns by 1,000 rows. So how we're going to run this test is we're going to add a new input here and see how long it takes to compute everything and update the output. So let's just put in, say, a number 10. And 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000, 11,000, 13,000, 14,000, 15,000, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30, 31. All right, so it took about 31 seconds. And I think you guys could see there that, there's this ripple effect as the formulas kind of refresh horizontally. So now let's do this with the array formula. So this sheet is essentially implementing the exact same math as the previous one, except that it's using array formulas instead of formulas that I had to drag every single row downwards and replicate it that way. So this will provide a substantial performance boost. So let's do the same thing. We input the number 10 and go 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, and we're done. So both spreadsheets are performing a little slower than they would if they've been open for a while more. But you can see that for the array formula-based spreadsheet, it updated all at once. So it doesn't have to propagate the formulas and update them the same way that it does when you drag formulas cell by cell. So it's more computationally efficient for spreadsheets at the cost of you're giving up a bit of flexibility because you have to make every single cell in the row essentially do the same thing. So there's this performance benefit that we can have. And in the case of, so my machine is actually a dual core 16 gig machine. So some math of this level complexity for about 200 columns and 1,000 rows, this is the kind of performance we're getting. If a lot of people, it's really common that you may have a 4 core 16 gig machine, and you're going to be, be able to push much closer to that, kind of 1.5 million cell limit with a pretty decent amount of calculations that you should be able to cover, a good amount of use cases with. So beyond array formulas, the next technique is name ranges. So, for those of you who code or, come from low code environments and things like that, variable naming is always a thing. And because code spends so much of its time being read, making it easier to understand and read is really important. Just from looking at the code, trying to figure out, the programmer's intention, what the code is trying to do, it's really valuable. It just makes things a lot faster and easier. So if we take a look at the example here, these two formulas do exactly the same thing. They're taking from exactly the same input ranges, but the one on the left has no name ranges. The one on the right has name ranges. And it's much easier to see, okay, when the developer wrote this, what was their intention? Hello, boy. Okay, let's go. Yeah, it's much easier to discern the developer's intention, okay, they're dividing property price by property size in square feet. So they're probably trying to calculate a, like a price per square foot type metric. And okay, the first clause of the if statement, they're checking whether, okay, property sizes have to be, 0 or more. They're probably trying to avoid, negative property sizes, which, don't really make logical sense. Or they're trying to avoid, zeros where, you get division by 0 errors. So, name ranges can help you discern this sort of thing. And in the context of spreadsheets, there are some kind of naming convention. When you design your naming convention, okay, boy, let's go down, let's go down. Oh, no, don't grab the laptop. Oh, okay, let's go down. When you're in the context of spreadsheets, there are some kind of considerations you're trying to discern with your variables, because remember, all of these variables are visible in the same spreadsheet. It's not like in other coding environments where your variables may be module or namespace based. In spreadsheet, it's all the same namespace. You need to distinguish all these things from each other, via good naming. So is this variable referring to data? Am I expecting it to be referring to an entire column of data? Is this a configuration value? Is this an array containing a list of allowable values that you're probably going to use in maybe a data validation dropdown? Is this a particular cell in a user selected value in an interface where they could be maybe inputting something, selecting something from a dropdown, or in the case of is this the name of a table? Which table might that be? What particular columns are you selecting in this name range, or is it everything? So these are sort of things you need to consider when designing your name range names in the context of spreadsheets. So, I have, been very positive about, the benefits that name ranges brings. And there are some arguments against it because one of the main ones is when you use name ranges, if you copy and paste the formula somewhere else, it's going to reflect exactly those name ranges that you used in the original copy. If you had like cell references directly, like A to A or A1 or B5, when you copy and paste these, Sheets will translate the cells appropriately. So if A1 was the cell to the left of what you copied, and you copy and paste this somewhere else, instead of A1, it's going to refer to the cell, one cell to the left of your destination. So that can be valuable. And in development, this sort of thing may make your development faster. So in the savings calculator that I'll be demoing to you later, I did allow for the computation of 2 people. And when choosing not to use name ranges and use cell references, just copy and pasting made that easier to replicate the second person out. But this does trade off readability in the interest of rapid development. So because the resulting formulas use cell references instead of name ranges, it's a little bit less readable, but it's a little faster in development. So my recommendation would generally be, use the dragging, copy and pasting in development, verify it works. In the course of your development session, you're not going to forget what it is. You're going to have it all in your mind. It's going to be fine. And then, switch it out to name ranges when you can, to clean it up, make it easier to maintain, and, make it easier for you to come back 6 months from now and figuring out what was doing. And in the context of copying, here's a little tip to make it a bit easier. You keep your naming consistent, like person 01 attribute A, or person 02 attribute A. When you copy your name range to a new set and you want it to become person 2 and use person 1 as a template, you can use find and replace within formulas to just with appropriate search strings. And that can help you with cloning out a second person, for instance. You do need to set the name ranges beforehand. And it's not as simple as a simple copy and paste, but you do get the benefit of readability, as well as your formulas are not locationally dependent on each other. So you're copy and pasting and using name ranges to direct where your formula refers to, rather than using, the column you're looking for is 3 columns to the left. It decouples it from that, which is nice for robustness and ease of maintenance. So now let's head over to the next tip, which is formula formatting. So similar to SQL, Google Sheets formulas are whitespace insensitive. So if you do have the liberty in choosing your own formatting style and something you can use to make it easier. It also does mean that I'm sure everybody who's played with SQL has probably inherited some code that it's just formatted horribly, indentations are arbitrary and things like that. Sheets code can be like that as well, but you have the option to fix it. I haven't found any really good automatic tools that can help with the formatting. So I tend to do it manually as I go along, but because I'm formatting as I write, it's not too onerous or arduous. So if we look at the slide here, there are these 2 formulas, they're exactly the same. If you just take out new lines and white space, they're exactly the same formulas, exactly the same name ranges. But the one that's up top is just easier to read. So here I don't have a nested loop, a nested if loop or if clause or anything like that. But if I did, if you put it all on one line, it's really hard to see where one function starts, ends, what's nested within each other, what are consecutive and things like that. My particular preference for Sheets formatting, at least, is whenever I open a function, all the arguments for it are one indentation to the right. So for example, the if function takes 3 arguments, the conditional check, what to do if it's true, what to do if it's false, and then a closing bracket. So that's represented exactly on 3 lines here. So every time I meet this level of indentation, I know it's 1 of the 3 if arguments. So I'm expecting 3 of those and then a closing bracket. For if error, it takes 2 arguments. One for what to do if there's no error. What do you do if there is an error? So, same for VLOOKUP, sets 4 arguments, and that's nicely represented here. So it makes it a lot easier to read. Whereas in the context of, if it's all in a single line, it works. It's just hard to read, harder to debug, harder to maintain, harder for somebody to figure out what you're doing and maybe expand upon it. So yeah, I personally do a lot of my formatting in a text editor. I use Vim a lot. I'm now using a lot of Visual Studio. So as you can use these tools too, because anything that helps you write code has a lot of stuff like helping you see where your brackets start and end. Sometimes they may automatically do the indentations for you as you go to a new line and things like that. So those are some options you can explore. The next one is the indirect function. So this helps with both readability and maintainability, as well as performance. So the indirect function doesn't do this out of the box. It's just that there are some interesting ways you can leverage it to achieve these ends. So what is the indirect function? It's a sheets function that accepts a string and it uses that as a reference to a cell range. So for instance, if I give it the string here directly as A1, it would interpret this as a cell reference A1. On the other hand, I could give it a cell reference or a name range, and that cell reference or name range could contain a string that looks like a name range, that looks like a range, and then Sheets would interpret it as that range. So what's really nice is that you can generate this via formulas, which allows you to say parameterize certain things, make it easier to maintain, as well as it allows us to get the benefit of array formulas referencing an entire column, being able to respond to changes in number of rows, as well as minimizing the performance overhead of having a lot of full column array formulas. So in the demo I did earlier, there's a lot of full column array formulas, which do take up a bit more overhead compared to non-full column array formulas. So putting D to D, A to A, and doing that over 200 columns, that's a bit more computationally intensive than using every single formula as 1 to 1,000. So I'll show how we can kind of get around this a little bit. So this is a little spreadsheet I had for demonstrating indirect. Let me close my other sheets just so that this loads a bit faster. So this is a similar sheet to what we had earlier. It's the exact same math, it's the exact same size. We have 1,000 rows and we go from column A to IY. But what I've done here is I've used indirect instead of direct cell references or full column array formulas. So we have the computation tab in this first tab called main. We have a reference tab that generates all these cell references as strings. So I mentioned that one of the benefits of full column array formulas is that your formulas respond dynamically to the number of rows in your spreadsheet. So currently I have 1,000 rows here, but say, what if one day my data expands or shrinks and there's a different number of rows. I don't want my formulas to break or need expansion. So what I've done is I have one cell here that just counts the number of rows in this particular tab. Currently it's 1,000. But if I expanded it to 2,000, say simply adding another 1,000 rows, that formula would update and it would change to 2,000. So just give it a second here. Updating, computing, and okay, it's frozen a little. My machine's a little warm today. All right, and we've updated to 2,000. So we still get the benefit of the formulas being robust against changes to number of rows. So this is the only formula in the entire spreadsheet that does a full column array formula check. And it's really just to return what is the last row number. So if you had a more elaborate use case where you had, say, multiple data tabs, each representing different data sets or data tables, you would just do one of these per tab. So even if each of your tabs had, like 50 columns, 100 columns, what have you, you just do it for once for each of these, and that would reduce your overhead quite drastically. So how do we then generate the overall references that we want to use when we actually want to process data? So I first use a kind of a regex extract formula and address to get the column of a particular output that is a string. And then I combine it with the first and last row references I had in the previous tab together with this, and I formalize it and output a particular range. So I have C1 to C2000, D1 to D2000, and so on. And you might ask, why don't you just key in the string C right here? Why are you putting this formula? What I want to do is make the data frames resistant to column insertions. So by having a cell reference directly here, it is a column insertion that helps to shift all the references as well, so you don't get these misalignments later on. So with that, I'm referencing the outputs in the ref tab, and I have that going forward same way all the way. I'm not using name ranges here. I'm just using the indirect with the, I like to call it like bounded formulas rather than full column. So it works the same way. I can put in an input. It's going to compute, and it will return a number in the green cell. So this would work on a similar order of magnitude compared to the array formula one. It's going to be slightly faster. It's not going to be as drastic a speed increase compared to the non-array formulas, but it will give you a performance boost and just help you get a little bit of extra out as we try and get towards the maybe that 1.5 million cell limit. So another benefit I mentioned is kind of maintaining a consolidated data reference, which makes it easier to understand what data is accessible in your spreadsheet, how do you access it in your formulas, and kind of abstract away where data is stored and how many rows does it contain, away from the formulas that actually need to consume that. So what do I mean by that? So let's take a look at this data directory demo. So I have one tab that's basically essentially my data directory. It's going to contain like what I name my fields essentially. So I name them with DD just for data directory to indicate that, okay, when you use these name ranges, you need to use them with indirect. They're not meant to be used directly without indirect. The next segment of the name is kind of the data frame or data set it belongs to. So everything with the same data set has the same number of rows. They're essentially just columns side by side that can be stitched together and treated as different fields in the same table. I have that nifty little formula here that checks your what's the maximum number of rows in each particular data set. So these would be the only formulas per data table or data set that actually use a full column reference. I have my regex address columns that I mentioned earlier. They're here. I have the field name. And I have the tab that this belongs to. So this would be kind of physically the tab that it belongs to. So I like to have flat static data that maybe I'm loading in via copy and paste or something in one tab. Places that I have formulas, I like to put in another tab. I don't like to mix static data and formula generated data in the same tab because that gets a bit messy. It's hard to tell what you can override, what you can't. And on the side, you can see I've got a whole bunch of name ranges. So I keep the name ranges consistent with the names in the name field. So you could look at this, and these would be the name ranges you could straight up refer to. So we'll just talk a little bit about the data set now. So in this particular demo, I'm using the Irish data set. I'm sure many people work with data. Have you played with the Irish data set before? So you have several numerical attributes like sepal length, sepal width, petal length, petal width, and 3 particular varieties of flowers, setosa, versicolor, and virginica. So what I've done is created some additional kind of mock dimension modeling data. So each of the 3 varieties could be from a particular geographical code, and then we have a lookup table for various geographical codes to specific countries and cities. So in the Irish Calc column, I'm trying to map the raw Irish data from the variety. I'm trying to derive their what geographical code they are in, and then therefore like what country and city the various flower types are in. So if we take a look here, I do use name ranges so that you can read it, you understand, from a logical sense, what data I'm trying to manipulate here. I use indirect so that we make use of our data dictionary, not dictionary, our data directory. We make use of that little trick where we only need to do a full column reference once. We make use of that. As well as, I have my formatting here so that you can see what's nested where. So just by looking at this, you can see that, okay, you're doing a VLOOKUP on the Irish variety, and you're trying to look up variety against the geocode table and looking up from variety to pull in the geocode. And in the next column for country, you're looking at using the geocode as a lookup variable to look up from the geocode to get the country. And for city, you're going from geocode to city. I think another thing worth noting here is I like, because I have this little additional if clause at the top, which refers to, for this particular variety column, if your value is same as the header value, I can just put my own title for what I want to name this particular new column, or what I want to use as a header for this new column. So this saves me the trouble from having a static header on row 1, and then having my formula start from row 2. One reason I like it is, you just have top row being all your formulas and values. Everything else is generated by the array formula. So if I've frozen my first row, maybe I've got a filter on, I'm doing some debugging, I can scroll down to row 1 to 2. I can inspect this value, look at my formula, look at this, all in the same frame. It's pretty seamless. So that's one of the reasons I like it. It does impose a slight performance overhead, but I found that the increase in readability and consolidation kind of outweighs that slight performance hit in my opinion. So that covers the indirect function, the data directory. And now I'm going to go back to the slide and we'll cover some general tips. So, outside of these general, outside of the specific techniques I showed you, there are some general tips that I think are beneficial in spreadsheets in general. One of them is, all cells consume memory. Even empty cells, they will consume memory when you open the spreadsheet. If you don't need the cells, delete them. Makes your spreadsheet a bit faster, a bit more responsive. And one of the ways in which you can do that is for each tab, just have one table. Don't have multiple tables side by side. So for instance, if I had 2 tables in the same tab, one with 1,000 rows, one with 500 rows, these last 500 cells, 500 rows worth of cells here, they're useless, but they're taking up memory, and it's not worth it. It's better to have more tabs, each one containing the exact number of cells you need, than to have one giant tab with a lot of empty wasted space just based on the longest or the data set you have with the most rows. Second one is, just be consistent throughout your spreadsheet with the color scheme you use. What color scheme you use is up to you, as long as you apply it consistently. I personally like to use yellow cells for a place I expect the user to key in something, or maybe select something from a drop-down, and green to draw attention to certain cells that may be returning a numerical output that's dependent on the user's input. When you want to display things like tooltips, the notes and sheets are pretty handy for that. So they're only going to appear when the user mouses over. So they're not going to take up screen real estate all the time. They're going to be useful when a user kind of maybe inspects a cell by mousing over it, Next, custom formulas. Custom formulas, they really grant you a lot of power and flexibility. You can really do a lot of things in them, but they do come with a really large performance overhead. So they don't really scale well into the thousands of rows and hundreds of columns. If you are using a fairly small workbook with not many cells, and you need that flexibility, go for it. But just be aware that as you grow in the number of cells, the performance hit from custom formulas will be much higher than that of the native Google Sheets formulas. So if you can even use a slightly more convoluted formula and do it in there, you might want to consider it just from a performance perspective. Secondly, just even aside from your name ranges, consistent naming conventions. What you call your headers, what you call your tabs, just keep it consistent. So that when somebody takes a look at it, they kind of understand what's going on. So coming to the little souvenir. Oh yes. So this is a, let me share the link to the spreadsheet, and then everybody, you can go to this particular slide. And the savings calculator link here is something that's it's a publicly available link. Everybody, feel free to copy it, and you can play around with it, expand on it, and so on. And either a use case may be interesting for you, it may not. You can take a look at how I've used the different techniques I mentioned. When did I make trade-offs of performance versus readability versus specific use case? You can open the link, follow along with me as we go through it now, or you can just look at the screen and dig into it later on your own. So this is a savings calculator I did for my personal use. The question I wanted to answer was, okay, if I follow this particular savings plan of saving this amount per month or per year, and I want to retire by this date this year, I want to have this amount of income in retirement. Will this plan work? Will I have enough money? So it allowed me to tweak with can I retire earlier, later? Can I tweak my retirement income, my savings plan, and how do these numbers line up? So that was the question I'm trying to answer. So the logic of this is, prior to retirement, I'm assuming to be working and going to be saving according to the savings plan that I key in. Once I retire, that stops. So while I'm saving, I'm going to have a portfolio that's divided into low risk and high risk investments with different return rates, which we can specify. And then after retirement, we're just going to be drawing down from that. I do allow for 2 people plan, as a couple or something, and both people will share the same portfolio. I didn't divide it in, each person having their own portfolio. I think if you want a use case where each person plan their own portfolio, you could just create 2 copies of this spreadsheet and plan it as 2 single people. So after retirement, income stops, and we start drawing down from the portfolio based on the desired retirement income. So I leveraged this particular strategy I read online called the bucket strategy. You can read about it at the provided URL here. So what it does over, let's say non-bucket strategies, I guess, is it tries to take out a certain amount in advance and use it as a cash buffer. So when the market's doing well, you can continue topping up that cash buffer. When the market doesn't do well, you can just draw from the cash buffer and not touch your portfolio, so you don't liquidate at an unfavorable timing. It gives you a bit of breathing room for the market to recover and your portfolio to recover in value before you start drawing from that portfolio again. So I'm Singaporean, we have CPF, we love CPF. You can choose to activate it or not. And you can choose which retirement sum you want, basic retirement sum, the full retirement sum, or the enhanced retirement sum. And next thing, I implemented this feature called the CPF Life Retirement Sum Inflation. So historically, CPF has increased their retirement sums for the basic, full, and enhanced. They've increased that year on year for the past couple of years at a very consistent percentage. So if you turn on the retirement sum inflation estimation, I'm going to help extrapolate that inflation of the retirement sum into the future. So if you're retiring 20 years from now and not next year, your retirement sum is going to be way different from what it is now, and using this can extrapolate it for you. If you don't feel comfortable making the extrapolation, you can turn this off and use the present day retirement sums. We have the bucket strategy link, which you can read up on your own time. I implemented a CPF life setting where, if say you want to go for the, the full retirement sum or the enhanced retirement sum, and maybe you don't have enough in CPF at the point you need to pay your CPF life premium, you have the option to decide whether do you want to just use what's in CPF life, pay that as your premium towards your CPF life annuity, or do you want to top up to you want to get the maximum, or either your targeted full or enhanced retirement sum. This is an option. I'll point it out in the UI again later. So this spreadsheet has gone through a couple of revisions. So I've added some features here and there. And one thing I will point out about this spreadsheet is that it doesn't have a large amount of tabular data that needs to be migrated from version to version. All the data that comes from the user is just manually keyed in this interface. So it takes maybe a couple of minutes tops for you to just key in your values. I can walk through it now, maybe 10, 15 minutes. If somebody's already familiar with the previous version of the spreadsheet, they could just go through it, have the old spreadsheet beside them, rekey in their values in 2 to 3 minutes tops. So the pain of migrating old data into the new version of the application or system, it's not present here. So that's one of the reasons why I felt spreadsheet's pretty good for this. So taking it from the top, first number, at the end of the entire simulation in the year that you think you're going to die, how much money is left in your entire portfolio? This is positive, means could be good, could be okay. If it's negative and it's red, means plan's not going to work, it needs revision. So first off, we have the first input, which is today's year. So the reason I put this here is just anchoring. You're going to key in a lot of your values in today's values. For instance, my expenses are $2,000 a month in today's dollars, and I'm going to retire in 30 years time. So inflation is going to 30 years. So putting today's year here and your retirement year later allows me to factor in inflation. So I do have, spreadsheet's not rendering. Let me just refresh this. But for those of you who have the spreadsheet open on your own machines, the color scheme I like to use is yellow for anything that the user needs to input or manipulate, green for anything that I'm returning a value based on my computations or based on the values you've put in. So today's year, the year you're going to start saving, because maybe you're a student, you're not going to have an income and be able to start saving until you graduate and have a full-time job or something like whatever it may be. Or maybe you have some big expenses you need to save up for and expend immediately, but your long-term savings is not going to start for a couple of years' time. You can put this year in the future. What your allocation in your portfolio between your higher yield and your lower risk is. You can put this in here. What you estimate the returns are. So this is not telling you. This doesn't tell you what's a realistic rate of return. It's really for you to based on your estimates, you put these values in here. Run the calculations, spit out numbers back to you. What kind of rates of returns you get, maybe depending on your own financial planning, whatever strategies you're going to implement. That's something you need to do outside of this and bring that value into here. What your high and low risk returns are. What kind of inflation values you're estimating. So based on what country you're based in, inflation is going to differ. Based on what kind of things you like to spend on, you may want to tweak the values a bit. So for instance, in Singapore, a lot of the inflation is based around, say, the cost of cars, the cost of real estate. But for instance, say if you've paid for your house, you don't plan to buy more property, that's not going to be regular expense. Maybe you're going to adjust your average inflation down. Or maybe if say dining out is a really big part of your lifestyle, and in your country, the cost of dining out's been increasing faster than the average inflation of most other things, maybe you're going to want to adjust this up a little bit, just to compensate for that. So the next setting is that CPF retirement sum inflation setting I mentioned earlier. So this is off. It's going to just use the latest CPF retirement sum, and it's going to use that no matter how many years in the future you're going to actually retire and be eligible for a CPF life. If you tick yes, I'm going to help you extrapolate, based on the year-on-year percentage growth we've seen historically. I'm going to extrapolate that into the future for you. So you may be able to have a much larger retirement sum and then therefore draw a much larger amount from your CPF life, which will affect how much you're going to draw from your portfolio to top up. Next, we have two different savings strategies, as I like to call them. One is free cash, one is savings commitments. Saving commitment is kind of the more conventional one that you see in a lot of places. I'm going to start, I'm going to save $500 a month, all the way until retirement. Or I'm going to save $500 a month, and every year I'm going to increase it by a certain percentage or a certain amount. So you start with, you define how much you want to save. Everything else is planned around that. The other strategy which I have available is called the free cash. I call the free cash strategy. So you're going to have your income. You're going to have maybe your CPF deductions, your income tax, your expenses. The remaining free cash is what you're going to put towards savings. So I created this particular implementation because as I can model my raises, my corresponding increase in income tax, my corresponding increase in expenses over time, I'm going to save the remainder. I don't need to worry about, is the amount I'm incrementing my savings too high or too low relative to my expenses and income increments over time. So this kind of aligns it a bit better for me. So I didn't have to make so many manual adjustments. So that's why I liked it. So let's go down the line and see what other fields there are. So there are two people in different columns. So how much savings you start with. Take note here that I did name this particular field UI savings input from person 1. So the one beside it is UI input savings from person 2. So they follow the exact same naming convention. One's P1, one's P2. If I want to clone, copy the formulas referencing person 1, person 2, I can do that in the back end. The amount of expenses per person, I put it in annual expenses because I think that's it's easy to factor in your monthly expenses plus your annual holidays, that sort of thing, one big number. For your savings commitments, do you want to do it as a monthly or annual amount? What's that number? And if you key in annual, I'll help you compute the monthly and show it to you. If you key in monthly, I'll compute the annual and I'll show that to you. So let's take the use case of, say, maybe I'm Jerry from the internet. 2021, he's going to try and start saving in 2023. He's maybe in college now. That's why he can only start saving 2 years from now. So maybe he doesn't have any savings. Maybe his annual expenses are $12,000 a year. Once he starts saving, he's going to try and save $12,000. Oh no, let's not do 12,000 a year. Let's do 12,000 a month. That's a bit more realistic. We're going to save $12,000 a month. He's going to try and increase that amount annually by 2.5%. And the kind of retirement income he wants in retirement is maybe about $3,000 a month. Jerry's born in year 2000. He's 21 this year. 2023, when he finishes college, gets a job, he's going to start saving then. Maybe wants to retire at about 55, and that will end up being the year 2055. Thinks he's going to live to about 90. May not live all that way long, but better to budget a bit more. Yeah, Jerry's Singaporean. He's got CPF, loves it, wants to use it. Got to max it out, going for the enhanced retirement sum, highest tier. If his CPF doesn't have enough at that point in time, he's going to top up from his portfolio, pay for the maximum amount of CPF premiums. Jerry hasn't started working. He's got nothing in his CPF accounts at the moment. Doesn't have any CPF commitments for the time being. Yeah, let's just leave this. You can ignore it because there's no CPF drain. Oh yeah, so I put CPA, OA, and MA drain are kind of recurring expenses that I chose to model in. So, for example, maybe you're making mortgage payments. Maybe you have recurring medical condition that you need consistent treatment for, that's going to make a deduction every year. You can to use maybe your MediSave for it. And in terms of income, what's Jerry thinking his starting gross basic annual salary is going to be? Maybe 30K as a fresh grad, maybe an annual increment of 3% year on year over the course of his entire working life. So all these figures are in. What does it look like? His overall savings value over time is going to look like this. He's still got a nice, healthy amount, about $1 million plus by the time he passes. How's that broken down, between the cash buffer for the bucket strategy, his portfolio low risk component, and his high growth component? Okay, it's pretty healthy. It's beginning to deplete a bit towards the end, so it may not last indefinitely. But he's got a good buffer. But what if he decides he wants to retire at maybe like 50? He thinks I've got $1 million at the end. Maybe I can play with this. I can just retire 5 years earlier. So what's that going to look like? Not practical. He's just going to run out of money really, really early on. And say, what's it going to look like if he retires at maybe like 57? A bit later than his initial plan of 55. Well, we see that his portfolio is not even decreasing over time. So if he follows this savings plan, even if he's immortal, lives forever, this portfolio is going to last him forever. It's just going to keep. The rate at which it's growing is faster than the rate he's drawing it down. So man's got options if he does it this way. So this is the kind of use case. I've got name ranges implemented. I prefix them with UI. It's something that I take from the user. If it's yellow cells for inputs, green cells for returns. The bucket strat calc is the area where I do a lot of the overall simulations year on year. So I have the year over here. Blue are cells where I actually have a formula in them versus white are cells that are generated by a formula, but they don't actually contain a formula. So a lot of these blue cells, I do reference the row above, items in the same column. So I had to use a dragged formula. I couldn't use an array formula for this reason. And I consolidated, say, a lot of my kind of system config values and data validation ranges and things like that. I consolidated them within the iron tab, or I call the index tab. So let's take a look at the name ranges I have in this spreadsheet. So for instance, everything in the bucket strategy tab, I prefix with bucket. Everything in, say, the index tab, I prefix with index. Anything that's, say, for instance, like a list of choices I want to use for my data validation. So this is, say, iron index CPF premium choices. So in the front end, the CPF life premium choices you have here, that's the data validation I use. So when you're looking at the name ranges, the suffix choices tells you that, okay, this is a name range that's going to be used as a particular set of available choices of data validation. A lot of the suffixes for, say, P1, P2, that's, like person 1, person 2. So if I was trying to clone it for a second person, I could use like that find and replace technique where I place all the instances of P1 with P2 in the new range. In the free cash contribution is one area where we can talk about. So in this area, we have the year, which is common to both person 1 and person 2, the total amount of free cash pulled from both person 1 and person 2. But everything after that is one set of values for person 1, one set of values for person 2. So a lot of these, I have them as cell references, and I could essentially copy a lot of this over from person 1 straight up to person 2. And everything that was a direct cell reference, just transition X number of columns to the right. So that was handy in development for me when I was trying to test things. And whenever I made changes, I found a bug or something, I'll fix it in person 1, copy and paste it with a person 2, and then just verify everything. I haven't gotten around to renaming a lot of these things to the appropriate kind of name ranges. So that's something I will do in future, just to make it a little bit more maintainable. And yeah, so a lot of them are reference tabs, index tab. So within, say, the bucket strat calc tab, there's a lot of computed values. As the simulation runs year on year, I capped the number of years I'm simulating at 500 because no way people are going to live more than 500 years. So this is a pretty generous buffer. And therefore, I felt, in this context, I'm limited to 500 rows max. So, the additional benefit beyond array formulas are going to the indirect references with where I only take the full column array length once. That additional setup and design, I chose not to use it because, hey, like the spreadsheet's already going to be pretty lightweight. The additional cost in development and the performance that I'm going to get, increase I'm going to get out of it, not super meaningful. So I didn't really prioritize that. And yeah, that's kind of the use case of this particular spreadsheet. It's available to everybody. Make your own copy. Don't put your personal financial plans in a shared copy. And yeah, so that's the spreadsheet calculator I have, and that's coming only to the end of the presentation today. This is my contact. My email, my LinkedIn, my GitHub. Yeah, so thank you everybody for joining today.